Awesome, so here is a short little tutorial on how to kind of use your graphing calculator just a little bit better for this week's set of problems. So as a quick review for the material overall, because knowing what the material is going to make using your calculator a lot easier. So we're talking about pH and POH and their relationship, but more than that, we're also talking about hydroxide concentrations and hydronium concentrations. So first things first, you're going to see hydronium in two different ways. You can see it as H plus or H3O plus. So if you see either of those, they're the same thing. So just make sure you're aware of that. So the way I like to look at these problems is that this kind of setup is pretty much like train tracks. So it can only go one direction or the other. So you can go all the way through one way or through the other way. So the equations that relate them are kind of specific on which direction you're moving. The only one that's not is from pH to POH. So the relationship between pH and POH is really straightforward. It's going to be pH plus POH is equal to 14. So if you have the pH, you can easily find POH or vice versa. The equations on the exterior are a little bit more difficult, so that's the real reason why we're having a calculator tutorial. But if you're going from POH to OH, your hydroxide concentration is equal to 10 to the negative POH. And then on the other side, it's the same. You're just going to substitute in a couple of those variables. So for that one, your hydronium concentration is equal to 10 to the negative pH. So you're going to substitute out POH for pH and hydroxide for hydronium. If you're going in the opposite direction, so let's say you have hydronium and you're trying to find pH, you're going to use a different equation just to make it a little bit easier. So pH equals the negative log of H plus. So I hope you're ready to use the logarithm key. Same thing over here, and again, just substitute out pH for POH and hydroxide for hydronium. Awesome. So again, it's really dependent upon which direction you're going for which equations you're going to be using. So we're going to do an example problem, and we're going to say that we are given the hydronium concentration. So let's say the hydronium concentration is, let's say 2.95 times 10 to the negative 2. So that is our H plus concentration. And we want to find the pH, the POH, and the hydroxide concentration. So we want to find all of those different variables, and the only thing we're given is hydronium. So that means we're going to have to go to pH. There's no way that we can go from hydronium to anything else without first going to pH. So when we look at this equation, we see that to go that direction, we're going to have to use pH equals the negative log of H plus. So we know that because we're going in that direction. So we plug it in. pH equals negative log of hydronium concentration. So we say 2.95 times 10 to the negative 2. pH equals. So now you likely have a graphing calculator. If you don't have a graphing calculator, go ahead and jump into one of those other videos. There's lots of tutorials. So we're going to say, make sure your calculator's on. The number one mistake I see is the first thing we type in. So a lot of students, instead of the negative sign, like to hit that subtraction sign. If you hit subtraction instead of negative, you're going to get an error. So make sure you're typing in that negative key. So hit negative just below that 3. So negative log. And the parentheses are open, which is important because since we have scientific notation, we're going to have parentheses around it. So parentheses 2.95. Instead of doing times 10 to the, we want to press as few keys as possible. The less keys we push, the less likely it is to make a problem or an issue or an error. We hit second function, EE, or times 10 to the, and again hit that negative 2. Same thing here, if you use that subtraction symbol instead of the negative symbol, you're going to get some type of error. Hit enter, and we get our pH. It's about 1.53. So just one more time so you can see it. You're going to do negative our log 2.95. Hit that second function, EE, or times 10 to the negative 2, close parentheses, and you'll get your answer. Awesome. So now we've gone from hydronium concentration to our pH. And our next step in our kind of train tracks, the only place we can go next is to POH. So from this, we know that pH plus POH is equal to 14. So that's our next equation, the relationship between pH and POH. The pH we just found was 1.53. Our POH is unknown, but we know that the sum of them is 14. So we subtract 1.53 from both sides and get that the POH, so 14 minus 1.53, is 12.47. So 12.47. Awesome. And then our final step is we're going from POH out to hydroxide. So since we're going out to hydroxide, checking those arrows and those equations again, we see that we're going to use that hydroxide is equal to 10 to the negative POH. So again, we're going to use that answer we just got. So hydroxide concentration is equal to 10 to the negative 12.47. So hydroxide, let's go ahead and plug it in. So for this one, same thing. We're going to say 10. We're going to hit that rooftop looking symbol. I believe it's called a caret. So you're going to hit that to the power of. Make sure again you're hitting that negative sign and not the subtraction sign. If you hit the subtraction again, it'll give you an error. So you're going to say negative 12.47. Missed that 0.47. There we go. Hit enter and we get our number. So it is 3.39 times 10 to the 13. So make sure you remember that that E key is for times 10 to the power of 13. So 3.39 to the power of 13 is very different than 3.39 times 10 to the negative 13. So make sure you include that. So again, plug it in, 10, hit that caret symbol, that rooftop just above the division, negative 12.47, and you get your answer.